So let me just ask you this. Is the very fuel you depend on actually slowly damaging your engine? It's a question you might not have ever considered, but with the way gasoline is changing around the world, it's more relevant than ever. So let's find out what's really going on and what a potential fix could look like.
All right, so our story really starts with this thing called ethanol-blended fuel. Now, for a whole bunch of environmental and energy policy reasons, more and more ethanol is getting mixed into the gasoline you buy at the pump. But this shift, well, it comes with a kind of hidden cost for a lot of the vehicles on the road today. And here it is. This is the core of the problem. Modern flex fuel cars, they're built for this stuff. But the vast majority of conventional engines, in our cars, our motorcycles, and other light vehicles, they were engineered for fuel with 10% ethanol or less. That's what we call E10. But today, blends like E20 or even all the way up to E50 are becoming more common, and that creates a huge mismatch.
And that mismatch, it can cause some really nasty issues. For one, ethanol can actually corrode the aluminum, rubber, and plastic parts in your fuel system. It also loves to attract water, which can lead to this thing called phase separation. That's where water and ethanol basically sink to the bottom of your tank and send this corrosive gunk straight to your engine. All of this just means less efficient combustion and, you guessed it, long-term engine wear. Not good.
Okay, so now that we've laid out the problem, the white paper we're looking at proposes a really elegant solution. And it's not about changing the fuel you buy. No, it's about treating the fuel right inside your vehicle with a very clever kind of filter. And the paper puts its mission statement right up front, no messing around. The goal is a portable device that can safely process fuel as you're using it in a standard internal combustion engine. Now, the key word here is adsorbent, and we're definitely going to get to what that means in just a second. The goals here are, well, they're both ambitious and really practical. It's not just about yanking ethanol out in real time. The whole design is focused on being reusable and having this slick, passive release system that uses the vehicle's own ambient heat. And it has to do all that while being compact enough to fit and without messing up your engine's performance.
All right, let's get into the cool science. How does this device actually sift the ethanol out of the gasoline? Well, it all comes down to a process called selective adsorption. Just think of it like a microscopic sponge, but one with specially designed pores. As the fuel flows over this material, the little ethanol molecules get stuck to its surface, but the bigger gasoline molecules, they just cruise right on by. It's a physical trapping process, not some chemical reaction, and that's absolutely key to making it safe and reversible. The whole process works in this continuous three-step cycle. First, you've got the adsorption phase. That's the filter doing its main job, trapping ethanol. Then comes the really clever part, the desorption phase. As you drive, the natural heat and airflow around the device gently warm it up, causing that trapped ethanol to just evaporate. And finally, in the passive dispersion phase, this harmless vapor is vented away safely into the air. It just keeps doing that, over and over, all on its own.
So, we've got the theory down, but what does this device actually look like? What's it made of? The system is built with both performance and, crucially, safety in mind, starting with its core components.
As you can see, we're talking about serious purpose-built materials here. The adsorbent itself is a specialized material like zeolite. The housing is explosion-proof steel, and even the fuel lines are specifically chosen to be ethanol-resistant. Every single component is picked for maximum safety and effectiveness.
And safety is clearly the #1 concern. The system cleverly avoids directly heating the gasoline. It only uses gentle ambient warmth. The vapor vent is routed far away from anything hot or electrical. And notice these specific engineering choices: leak-proof seals, and anti-static and explosion-proof housing. These aren't just ideas, they are features engineered for real-world safety.
Okay, we've seen the problem and the proposed solution. So now for the big question. Does it actually work? Let's look at the expected performance and what makes this whole concept so promising. This is the headline number right here. The white paper projects that this device can remove between 50 and 90% of the ethanol from the fuel with each pass through the filter. That is a massive reduction. We're talking about bringing high ethanol fuel way down to a level that is much, much safer for a conventional engine.
And visually, the effect is just this dramatic drop in ethanol. The fuel goes in at a high, potentially harmful level, and after passing through the cartridge, it comes out at a level that's way friendlier to the engine. It's a simple picture that shows you the device's entire purpose.
Now for the practical side. You might be wondering, how often would you need to deal with this filter? Well, the design calls for a single cartridge to last somewhere between 200 and 500 kilometers. That's about 125 to 310 miles before it's full. At that point, you could just easily swap it out for a new one or a regenerated one.
So, when you pull it all together, the advantages are really clear. It's compact enough for almost any vehicle. Its passive operation means it doesn't need its own power source. That's huge. It's scalable, it's modular, and by avoiding any contact with water, it sidesteps a major risk of other fuel treatment methods. It's just a very clean, self-contained system.
And that leaves us with this final thought. As fuels keep changing, millions of perfectly good cars, classic vehicles, and motorcycles are at risk of premature wear and tear. So could a simple, passive device like this be the key to protecting them, bridging the gap between the fuel of tomorrow and the engines we have today? It is definitely a compelling question to